Thanks, Hannah. I'm Johnson. Hi, everyone. I'd like to discuss the following part of this project. First, let me introduce the motion flexibility control. In this part, I'd like to discuss why the robot does not work smoothly and the flexibility when during the imitation user's motion process. As it is shown in this picture, the motor's complaint has integrated their control model into this simple way. It shows that this is the complaint slope, this is the complaint margin. So there are two ways to solve this problem. The first is the complaint slope. If we make the slope as smooth as possible, it means the action of the robot will be smooth as much as possible. If we make the complaint margin as small as possible, it means the action of the robot will be more accurate. Complaint margin is the present position, the difference between present position and goal position. So, next one is the motor rotating limitation, which means the mechanical limitation of the motor. As shown in this picture, this is a construction of the motor. The valid angle range is from 0 to 300 degrees, and here this part is unvalid degree range. So in that case, we only can use from here to here. So in this way, take the shoulder rotation, for example. You can see here, this is the rotating part of the arm in the robot. We design this part like this way. The motor will be placed like this way. So it can move from 0 to 150 degrees and then continues to move from here to 300 degrees, just like this. From here, 0 to 150, and then continues to move to 300 degrees. This area is unvalid, so if people top his arm like this way, it will be designed to move to this way, or in this way. Next rotating limitation is the robot's frame. Because of the constraint of the bracket, as we all know, people's arm is more flexible. They can move the degree even less than 30 degrees, which is shown here. However, in the robot, we can't do that smaller degree, because here you can see the picture. This angle alpha, we can only make it bigger than 90 degrees. If it less than if it is less than 90 degrees, there will be a crash between the motor and the bracket. So in order to protect the mechanic part of the robot, we need to add a limitation inside the program to avoid this crash. Another important model is pre-designed motion model. In this model, we design some special human gestures such as shaking hand, growth step, jumping up, and awesome. During the process, we use Kinect to allocate the positions of every joint in the real body and calculating goal position of each model, and then send the data to the computer, and the computer send the data to the robot to make the robot display the motion. These motions are integrated together and playing circularly. The function of it is to make it more attractive. During the indirect explore, we make it to attract more and more attentions. So you can see here, this is a sequence of actions. This is shaking hand, this is cross step, and this is jumping up. It's more attractive, I think. So the next one is the pre-recording model. This model will record the user's motion for a short period and then ask the robot to display what the people have done during this period. During the recording process, Kinect is applied continuously to locate the position of every joint of the red body. And the frequency of the Kinect is 30 Hz. We suppose the time period is 10 seconds. So that 300 data streams will be collected during this period. It will be stored into a buffer. However, we only need to select some of this data packets because there are two reasons. The first reason is the limitation of the process speed of the main controller, CN5. If sending the whole 300 data packets to the controller, the 10 seconds period will display for only will be more than 30 seconds. It means the motion of the robot will be much slow. The second reason is that the angle margin between each packet is small. As we either collect 300 data packets, the angle margin between each packet is much small, which means it is hard to distinguish by eye. Consequently, enlarge the angle margin between the adjacent packet is a must. So if we improve the margin between each data packet, the performance will be improved. During the design, during this project process, there are some problems. The first one is limitation of motor's temperature. As shown in the website of the robotics company, the running temperature of the motor range is -5 degrees to 70 degrees. If overheated, it will stop work. Consequently, it can not work for a long time. And that's the reason why we take off the teddy bear skin off during the Indera Expo. The second one is the power supply. The battery pack only powered the roll system for only less than 20 minutes because the more motors are used, the more power will be consumed. As a result, we're using transform to power the robot directly. The last one is the wiring connection, which is confused us a lot. Well, the wiring connection is not always stable, especially mimics the crazy actions. Motors are connected in series, so if one motor's connection breaks, the others will be stopped. Last part, conclusions and future work. Our project has 4 main motors: real-time imitation play, speech recognition, pre-designed motion display, and the pre-recording. So I think during these 4 motors, the most important one is the real-time imitation display. During the Indera Expo, it has attracted many people's attention, and I always say it is funny. And the balance problem, I'd like to say we will want to solve it in the future, because if we solve the balance problem, it will be work like this way. The whole system can mimic whatever you want to do, and whatever you don't want to do, and just ask it to do it. So that's all. Thank you.